All right, so in this section, we will be learning our next derivative rule, which is called the chain rule. And this is used to find the derivative of a composite function. So as we know, a composite function is a function, f of g of x. We usually like to call it a function inside of another function. So the way we find the derivative of a composite function is really by taking the derivative of the outside function. So usually we call that f of x, and multiplying that by the derivative of the inside function. So the definition is here and you can read that, but I think it'll make a little more sense once we look at examples. So first, this function here, we have x squared plus 1 all cubed. So our outside function would be something cubed. And then the inside function is x squared plus 1. So to take the derivative of that, so dy dx equals the derivative of the outside function. So using the power rule, that is the derivative of the outside function. And when we do that, we keep the inside the same. So that's the derivative of the outside part. Then we multiply that by the derivative of the inside. So the derivative of the inside function would just be 2x. And then just simplifying that, since this is multiplication, 6x times x squared plus 1 squared. And that is our derivative using the chain rule for number 1. Let's see if I can squeeze this in. So let's go like this. So number 2, so this is also a composite function. We've got x squared minus 1 all underneath a square root. Now, normally you know that we like to rewrite our square roots as exponents. So we're still going to do that here. So we're going to have x squared minus 1 and then to the 1/2 power. So now this kind of looks similar to the last one here. Our inside function is x squared minus 1. Our outside function is this whole thing to the 1/2 power. So f prime of x, we do the derivative of the outside, which is 1/2 x squared minus 1 to the negative 1/2 power, and then times the derivative of the inside, which is again just 2x. And then simplifying that, we have 1/2 times 2. So those will cancel each other out and we'll just get 1 x. And since this is a negative exponent, I guess we can do that in 2 steps. So then we have x times x squared minus 1 to the negative 1/2. And then over here, I will move that to the bottom. So we have x over x squared minus 1 to the 1/2. And that is our derivative using the chain rule. That's a minus sign right there. All right, so moving down to our next one. All right, so g prime of t, this is our function g. Now, here's what we'll do. We could use the quotient rule here, but that's going to get really ugly. So we're going to rewrite g of t. So this isn't the derivative yet. We're just rewriting g of t as -7 times 2t minus 3 to the negative 2nd power. Now, the reason we can do this is, the reason we want to do this is so now we can just use the chain rule. We don't need to use the quotient rule with the chain rule in it. This is just chain rule. So now we do the derivative of the outside. So this -2 comes down in front times -7 would get us 14. And then 2t minus 3. And then -2 minus 1 is -3. And then times the derivative of the inside, which is just 2. So this leaves us with, do 2 steps in 1, 14 times 2 is 28, and we'll move that negative exponent to the bottom. So 2t minus 3 cubed. And that is our derivative for number 3. All right, so let's go back to red. So number 4, this one we're also going to rewrite this to make our lives a little easier. So again, we could use the quotient rule, but it's a little easier if we just rewrite this way. And now it changes from a quotient rule problem to a chain rule problem. So we do the derivative of the outside. So -1 comes down in front. Inside stays the same. Subtract 1 from the exponent. And then multiply by the derivative of the inside, which is just 9x squared. I'm going to simplify this. So we have -1. -1 here times 9x squared gets us -9x squared. Then I'm going to move that negative exponent to the bottom. So 3x cubed plus 4 squared. And if you did this using the quotient rule, you would end up with the same thing. It's just a few more steps. So eventually it's up to you whether you would rather use the quotient rule or the chain rule. All right, so moving down, we've got some trig functions here, of course. So this function here, we have y equals cosine x squared, which just pointing out that is the same thing as cosine squared of x. So when you see cosine squared of x, you just need to remember that that is the same thing as cosine x squared, so you need to use the chain rule when taking the derivative of that. All right, so y prime, so the derivative of y, we will do the derivative of the outside function, which is something squared. So 2 cosine x to the first power times the derivative of the inside, which is negative sine x. Simplifying that is -2 sine x cosine x, and that's it. All right, so next one over here. We have 4e to the -2x. So in the past, we've only taken the derivative of e to the x. But now this is a composite function, outside function being e to the x, inside function being the -2x that's inside of that exponential. So when we take the derivative, we do the derivative of the outside. So the 4 is a scalar multiple, so that stays outside. And then we know that the derivative of e to the anything is just e. It's just itself. So this is going to be e to the -2x. But then it was more than just an x up here, so we need to take the derivative of our inside function. So times the derivative of -2x, which is -2. Simplifying that, we get -8 e to the -2x, and that is it. So the thing to remember is that if you have a function with e and there's more than just an x in the exponent, you need to use the chain rule. So you do the derivative of the outside, which is still just itself because it's an e function, times the derivative of whatever was in that exponent. In this case, it was -2x, so that's just -2. All right, moving down. So this one, there's a lot going on here. So this is a product, first of all. So we have 5x squared times secant of 3x. So this is a product because this is multiplication right here. However, this second part of it right here, secant of 3x, that is chain rule because secant is the outside function and 3x is the inside function. So in the previous unit, we did learn the trig derivatives, but in all of those trig derivatives, it was just secant of x, sine of x, cosine of x. There was nothing else inside of it. So when there is something besides just an x on the inside, you need to use the chain rule. So we're going to use product rule and chain rule at the same time here. So y prime equals, we do the derivative of the first, which is 10x, times the second, which is secant of 3x. So this is for number 7. This is going to run over underneath number 8. So the derivative of the first times the second plus the first times the derivative of the second. Now the derivative of secant is secant tangent, so that's secant 3x tangent 3x. So that's the derivative of the tangent 3x. Should probably fix that. That's kind of ugly. All right, so that's the derivative of secant. So that's the derivative of the outside function, but we need to remember that we had an inside function, which was 3x. So we need to then multiply by the derivative of 3x, which is 3. So I'm not going to go crazy with simplifying. Let's just change this to 10x secant x. That's going to stay the same. So 10x times secant of 3x, and then plus, we're just going to multiply this 3 with the 5, plus 15x squared secant 3x tangent 3x. And that is our derivative, that whole thing there. All right, so now I'm going to have to erase this to do number 8. So number 8 has to do with a natural log. Now again, in the last unit, we did learn the rule for natural log. The derivative of that is 1 over x. But for this one, so for number 8, there's more than just an x on the inside here. We've got a function inside the natural log function. So when we take the derivative, we need to use the chain rule. So the derivative of natural log of something is 1 over whatever that something is. So it's 1 over 4x squared. That's just the derivative of the outside function, so the derivative of the natural log, and then times the derivative of the inside function, so the times the derivative of 4x squared is 8x using the power rule. And then, of course, we can simplify that. So 8 divided by 4, we're left with 2 in the numerator. And then we have an x in the numerator and an x squared in the denominator. So we are just left with 2 over x. And that is it. We will do the rest of this in class because they're a little more complicated.